So welcome to Setup Track Throttles. In this video we will do exactly that. And by the end of it what we will have is something like this, where ignore what's going on the screen on the 3D viewport, just look at the console. I have now got left and right track throttle values coming through from my gamepad, which is pretty cool, and there are several changes that have been made to make that happen. So let's go and have a look. Then we don't currently have a track class. We do have a barrel and a turret class, both of which were inheriting from static mesh component, but when it comes to the actual tracks, they are just raw static mesh components with no ability for us to write any C++ code. So that's the first thing I'm going to want you to do, is base tracks on C++ classes. Create a tank track class, inherit from uStatic mesh component, make it blueprint spawnable, very much like the barrel and the turret. In fact, this whole thing is very much like the barrel and turret. Replace the tracks on the tank blueprint and put the meshes back, and then just test that the game still works. Nothing will change, but you will, very importantly, have a C++ class in which you can write behavior about the tracks. So pause the video and base your tracks on a C++ class now. Go on, you can do it. It's just like the barrel and the turret. Okay, welcome back. Let's have a little look at this. So we're going to make ourselves a new C++ class. It's going to be a uStatic mesh component, so we're going to have to show all classes. We're going to type static mesh component. There it is. Going to call it tank track. Perfect. Create class. Leaving this public checkbox set, remember that just makes header files go in a public folder and C++ files go in a private folder. We're going to keep it like that for now, just for simplicity and for consistency with other Unreal tutorials, particularly the ones made by Unreal themselves. So while that's compiling up, why don't I go take a look? Oh, I can't. I'll just be patient in that case. What I will do, actually, is go take a look at the turret. This is the meta equals blueprint spawnable component annotation that I need. So I'm going to grab this blueprint spawnable component. I'm going to get rid of the hide categories comment because we aren't going to hide the collision category. So I'll get rid of that. It's extra commenting we don't need. Going to go to the tank track header file, put in the meta blueprint spawnable component. Now remember what that means. That means that in the tank blueprint at the moment, if I do the drop down and go to custom classes, I have a barrel and a turret, but no track. If I compile my code with this header tool directive in this blueprint spawnable component, then, well, let's do it. Then it will appear in that list. While it's compiling, I want to do another thing. Look, if we look in here at left track, you see it says static mesh component, then it gives us a load of grey text, which tells us about what a static mesh component is. But right now, if I come in and add myself a tank track, which is now available, and then say left track, well, I'll do the left track in a minute. Look, if I hover over it, it's got no information. Okay, so let's give it some information. That information goes here in that comment block. So let's just look at the static mesh for inspiration. Static mesh component is used to create an instance of a uStatic mesh. Okay, so tank track is used to set maximum driving force and to move the tank, or to apply forces to the tank. Okay, so that comment there, when you compile, will come through to this hover over menu there where it says tank track brackets tank track. We'll then usefully get a little bit more information about it. So do get in the habit in your C++ of decorating new classes with some information like that, so that when you hover, you get that. Cool, so what is it about the left track that we need to replace? It's just the static mesh. So this new tank track here, just going to replace it with the tank track static mesh. I'm going to delete the left track now. Still got the right track if we wonder about any properties. Call it left track. Parent the socket to left track. Check the viewport that the tank still looks feasible. Compile up the blueprint. And let's play the game. Left track looks very much like the right track, but the difference is if you hover over the left track, it's based on our C++ class, whereas the right track is a plain old static mesh component. Great. Let's now just run this from the main menu because we have had problems with that before. Yep, it's all working fine. Great, so I'm now just going to do the same for the right track. In fact, I'm just going to delete the right track, duplicate the left track, call it right track, change the socket, and compile and save actually the blueprint. Now let's play the game from the menu. And it works absolutely fine. Great. So that's a good starting point. In under 5 minutes, we have ourselves a pair of tracks that give us C++ code that we can access. Cool. So what we want to do now is drive the tank with that. So we're going to need to give ourselves an input for a start. So under the project settings, go to input and create yourself a new axis mapping. I'm going to call it left track throttle. Now this is the sort of thing the player would actually see when they are setting up the controls for themselves. I'm going to use the left trigger. There you go, gamepad left trigger. And then I'm going to make a right track throttle. And I'm going to make it the gamepad right trigger. Gamepad right trigger axis. Now you want gamepad left trigger axis as well. Not trigger, but trigger axis, okay? Because we want it to be analog. You want a variable amount of throttle. So they are the action mappings that I've set up. Fantastic. I'll leave this open just in case I need it. Then what we want to be able to do in the input setup of the tank is outside of this block, which is no longer, by the way, just camera input binding. It's more generally, because it's got fire information here, it's aiming input binding, isn't it? So this block on the right here is about aim input binding. So immediately you see that a comment's not right, just change it. And what we want to be able to do over on the left here is we want to be able to go, okay, let's go find this throttle thing, which is the left track throttle event coming in. And we're also going to want the right track throttle. They are the input bindings we just set up. And we're going to want a blueprint callable method that does something with that. This axis is going to spit out a value between -1 and +1. Well, it could be bigger than that if the scaling is changed here, but by default it'd be between -1 and +1. Mental note for later, we may want to do some clamping inside of our actual throttle code to make sure that a user can't change their scale and make the tank actually go any faster. This just wants to change how controls feel, not how the tank behaves. But anyway, we want a bit of drag out of here, run a blueprint callable event, and then pass in the axis value. So in order to do that, we're going to need to make ourselves a public section of the track. Then we're going to need something like void set throttle, or throttle request. What should we go with? Throttle request. No, set throttle. You can set a throttle directly. Set throttle, float throttle. Okay, so that's great, but that's not going to be blueprint callable unless we say that it's a U function. Blueprint callable and category equals input for neatness. Okay, so we have a blueprint callable function there. So before I go and try and compile this, let's implement this function. U tank track set throttle like so. And I think the first thing we should do is just log out the value. It's always a good thing to do. So let's search for UE log in the current project. Go get this log that we previously had in the launch projector. We don't need it anymore. Let's cut it so that we've only got a log in one place. In the tank track, let's paste it. And we could say, instead of the time, in fact, I think I'm going to not use the time for now. I'll keep it for the next thing, but I think I'm going to say auto name equals get name. See what that comes out as. And as a string, I'm just going to say this track's throttle colon, and then we're going to print out the throttle. That should work. I think this auto name get name should work. Should come out as an F string with a star on it. I think that might work. Let's try it. It's going to be quicker than waiting for Unreal to, Visual Studio to autocomplete. Let's see if that's going to work. So the idea is I'm going to say left track throttle set to, and then it's going to show me, and well, it won't until I actually wire it up, but we can wire it up in the blueprint in just a second, as soon as the compilation has happened. Yeah, cool. So now the compilation has happened, we should be able to look for something called throttle, set left track throttle function. There's your blueprint callable function. Again, if you want sensible comments on there, you can put comments in the top of the, just above the method here, this set throttle. You can do it in the header file, for example, and you can come in here and just say, set, say, throttle between -1 and +1. And if we were to compile that up, And next time we go for set throttle, we should get something a bit more helpful. But while it's compiling, let's wire in the axis value to the throttle input, the float. I'll put the left track in the middle. It's a bit ugly, but it's better than things crossing over. Let's look for throttle again. Set throttle on the right track. You see, sets a throttle between -1 and +1. That's helpful. And that happened, as I say, because I put a comment here above the function. Okay, so there is the right track. Let's just pull the value through, compile this blueprint, and go have a look. If it compiles, save it in case it crashes, compile, play, in we go. Now I'm using my gamepad. I'm turning on the gamepad on my computer. It's an Xbox One gamepad in this case. We have 0 reports of throttle. Forget what's going on in the main game screen. Let's focus entirely on this output log at the bottom left. Look at that. I'm pulling my left track throttle between 0 and 1, and the right track between 0 and 1. Awesome. That's working perfectly. Let me just show you one other thing, this input scaling. Let's turn the left track throttle input scaling to 2.5 so you can see what that's doing. Now if I pull the left track in, it goes between 0 and 2.5 at full travel, but the right track can only go to 1. Now that's a bit weird. We don't really want that to happen. We do want to limit the full travel because at the moment, if we let this carry on, the player could change. If you give the player this control over this axis speed, its control sensitivity is what you'd normally see in menus, then they would actually be able to make the track go faster. So we're going to want to clamp these values later. So when you have a thought like that, put it in. It's going to be in here somewhere in set throttle, and we're going to make a to-do clamp actual throttle value to so player can't overdrive or something like that. Just capture your idea that you want to do that. That is fantastic. I'm not going to actually put in the applications of the forces, I don't think, in this video, because we're going to have to think about how much force needs to be applied and a few other things, and we've done enough for this video. So as a quick recap, what we've done is we have based our left and right tracks on our own classes, which are in turn based on static meshes. We have wired up some throttle input mapping like this, so by making some axes, providing references to the tracks, and then passing the axis value through into this throttle method. We've then written this throttle method that at the moment just prints. So pretty cool. Good work for one lecture. See you in the next one.